This presentation is about a new feature for FEM Composite helmets available in RMBridge since version 11.04. In this video, we'll see how to create one hybrid solution and one complete FEM model from one beam grillage, and we'll compare the final results for the three deck models. In RMBridge, it's very easy and simple to change from one 3D composite beam model to one hybrid FEM model or to a complete composite FEM solution. In RMBridge, stress FEM values are integrated over the whole deck cross-section for getting the final results in beams, where at design code checks can be performed as a standard form. This new feature in RMBridge corresponds to a very powerful and wise tool for FEM composite models generation. So let's see how to do it. In this verification example, we have three similar composite grillage models. We are going to keep the first model at the left as a 3D composite beam model, transform the middle structure in one hybrid FEM model, and the third one in a full composite FEM model. We have defined some construction stages from where we can see the summation load-cut results for the longitudinal bending moment, for the secondary results, and for the total results. Now we go to Modeler and open the cross-section 2 to introduce the shell elements in our hybrid FEM cross-section. As slab belongs to part 1 in our composite section, it's necessary to be sure that part 1 is activated and shell elements will be added to that part. I'll use shell element, automatic subdivision, and change subdivision part position commands for placing elements and intermediate nodes as intended. In main girders, we'll select the option for FEM modeling for the slab elements. So for the full composite FEM model, we go to cross-section 3 and do the same steps for all the parts in the cross-section. It's necessary to assign slab shell elements to part 1 and girder shell elements to part 2 in this example. We can always edit shell elements and verify the beginning and end nodes and part if they are well defined. In main girders, we assign FEM modeling to all the part elements. For a full composite FEM model, some attention should be given to the connection support elements. for being sure that all the restraints are well defined before and after the support node. Now we can recalculate modeler and check if everything is okay. We have a new 3D visualization by changing the display options, where is introduced in the model some transparency that will permit user to see all the elements defined in the bridge modeler. After we send this model to analyzer and initialize all analyzer data. So at this stage you can add the schedule actions, where we have defined the construction stages, remain load, additional loads, live loads, envelopes, and what we need for our structural analysis. Through the defined schedule actions can be introduced different plots or diagrams that are very useful, as user can quickly see if there is any problem or issue with the bridge model definition. Now that the deck model has run, we can check and view some results. Let's start by the results in BIM elements. When we want to see results in the main view, the best way is first to prepare the view options. If we want to see results in BIM elements, it is necessary to deselect options for FEM. And as you want to see results only for the longitudinal beams elements, the easy way is to create one RM set where those elements are assigned. We can go to results and present the wanted diagram, for example, MZ for the summation load case. We can see results in envelopes of live loads as an example, where we can see a very good behavior between the three analytical models. For live loads shell results, Bridge has tools that allows user to store results for the chosen elements and sections, and after they can be used for the deck slab design. This was the new feature for FEM Composite in Bridge.